Now let's consider the compound event A and B. This is the event of both A and B occurring. For the multiplication rule, we are now considering events which occur in successive trials. For instance, event A occurs in the first trial and event B occurs in the second trial. And so the multiplication rule that we're seeing here uses the conditional probability of event A and the conditional probability of event B given A. So we'll think about what this means in a moment. But here let's think about independence of events. So we say two events are independent if the occurrence of one event does not affect the outcome of the other event. So in other words, their conditional probabilities are not changed by the conditioning event. Okay, so looking at below here, we would say the probability of B given A is equal to the probability of B. So that's saying that the probability of B occurring is not affected by the event A. And so the probability of B given A is equal to the probability of B. And symmetrically, we could say that the probability of A occurring is not affected by whether or not the event B occurs. So whether or not B occurs does not change the outcome or does not change the probability of event A occurring or not. So that would be the same as the probability of event A given that B occurs. So let's think of an example of two events that are independent. Well, let's think, for instance, if I'm flipping a coin, every time I flip the coin, the successive flips are not affected by the previous flip. So we would say those are independent events. But let's think of a case where maybe we have dependent events. So those are events that would affect the outcome of another event. So what would be an example of some events that are dependent? Well, let's take a case where I have the event A is whether or not I wear a jacket on a particular day. So let's say it's the event of me wearing a jacket today. And then event B will be whether or not it rains today. So I would say that these two events are dependent because, say, on any given day, maybe I have a 20% probability of wearing a jacket. On the other hand, if I'm given the knowledge that it's raining today, that might change the likelihood or make it more likely that I would be wearing a jacket that day. So we would say that those two events are dependent because the event B, that it rains today, would affect whether or not I decide to wear a jacket that day.